Hello everyone, welcome to my DIY channel. Now let's get into the video. As you can see, the tip of this soldering iron is badly burned. It has lost the special coating that helps solder stick to it. I'll show you what this problem looks like in practice. Here's our solder wire. It's standard type, made of 63% tin, 37% lead and 2% solder oil in the wire core. You can clearly see that the tip of is so burned that solder won't stick to it. The coating is completely gone and this makes soldering very bad. This makes our soldering work difficult, especially when assembling or repairing a circuit. We can't get the solder to stick properly to the components or pads. Imagine you are fixing or building something. Your soldering iron is always on, and if you turn it off and on again, it wastes time heating up again, and you may not have the time or patience for that. Over time, because of the heat, the tip gets damaged and the layer that helps hold the solder burned off, so you can't solder easily anymore. So what can we do to solve this problem? I have found a useful solution. Since mains electricity alternates between positive and negative, we can use a diode to let only one half of the cycle pass through the iron. These are our switches. I prefer a two-position switch. The first position gives us half power, the second position gives full power. You can use any kind of switch, even rocker switch work well, but I prefer a small, neat, double throw switch. It has two positions, position 1 and position 2, and I'll show you how to use it in the circuit. Here's the diode. We are going to use preferably a CMOS Schottky diode because it can handle high voltage and it's suitable for our purpose. This is our switch. It even has a small schematic printed on it. I'll zoom in to show where to connect the lead and where the soldering iron wires should go. We install the diode on one of the switch terminals. The direction of the diode doesn't matter. Here, anode or cathode can face either way. I suggest thinking about where you want to mount the switch for the best appearance. I like putting it on the cable of the soldering iron so I can easily switch modes while working. But it's up to you. You can even put it on the plug, although that may be harder to access. Let's install the switch. We cut the cable using side cutters and measure how much wire we need and where the switch will be placed. Test the placement before cutting anything. To avoid mistake, we only need to cut one wire and install the switch in between either the live or neutral wire. I opened the soldering iron to apply varnish for a better look, but you don't need to do this. It's easier to just cut one wire and thread varnish later. Inside the soldering iron you can see it has a potentiometer which controls how a capacitor charges a diode. The diode then triggers a triode to turn the power on and off, and this controls the tip temperature. I threaded the varnish tube into the iron. I twisted the wires together to pull it through it. It was a bit hard, but it gave a nicer result. I recommend just cutting and threading the cable without opening the iron. It's simpler. I pulled the varnish out from the other end so I can work on it more comfortably. Now we reassemble the iron carefully. The ceramic parts are fragile and can break easily. Secure the cable clamp. Now we thin the cut wires and also thin the switch terminals. This ensures better soldering. Use another soldering iron for this part. If you don't have a second one, maybe you can borrow one. Otherwise, it's hard to continue without it. Solder the output wire of the iron to switch, then cover everything with varnish and use heat to harden it. I mounted the varnish directly on the switch so it fully insulates the connections. Now we need to connect the diode so that one end goes to terminal 1 and the other end to terminal 2 as shown in the diagram. This type of switch works by connecting terminal 1 in the first position and both terminals 1 and 2 in the second position. Make sure you use the correct switch for this setup. I'll add the specification of the switch in the description. Secure everything with hot glue. Once it dries, add varnish again and apply heat to finish the insulation. Use pliers to shape the varnish tube so it fits snugly around the cable. I also used a larger varnish tube to make sure the entire assembly is insulated properly. As I mentioned, you can use pliers to heat and press the varnish tube around the cable for a clean, tight fit. Now we cut a hole just the size of the switch so it can move freely and work properly. Let's test it in half power mode. Only the diode is in the circuit. The other input wire goes around the diode, so in position 1 only half of the electric cycle passes through the iron. If your soldering iron is 60 watts, it now works at about half power, generating lower heat which prevents the tip from burning. I'm keeping this video uncut so you can clearly see how it works. We wait for about a minute. Ceramic soldering iron usually take around 1 minute to heat up. Then I'll explain the results. In half power mode, if the iron is rated for 60 watts and set to 200 Celsius, it actually operates around 100 Celsius. When switched to full power, it runs at full watts and reaches its true temperature. Now the iron is in half power mode. You can see the tip isn't getting hot enough to melt the solder easily. This tells us that when you are not actively soldering, you can keep the iron in mode 1 to keep it warm without damaging the tip. Now switching to mode 2, full power mode. The iron runs at 60 watts and 200 degrees. This mode, solder melts easily and the tip won't get damaged because we only use full heat when necessary. This tip is already burned. I need to replace it, but you can see that even now solder melts easily at 200 degrees. So when you need to solder, use mode 2, and when you are on standby, use mode 1. It keeps the tip warm and ready without burning it. I also added a main power switch so you can turn off the whole thing easily when not in use. Thanks for watching and please support the channel. Goodbye. Don't forget to like and subscribe.